Hello, this is Steve Palladino. I'm a coach and consultant of Palladino Power Project. I'm going to go over a video today that goes over a sort of a workbook that I put together that allows people that run with power to work within multiple variables of altitude changes or heat or humidity changes. Um, the the fact is that we don't always train in the same temperature. The climates change throughout the seasons. Sometimes we go to an altitude camp or what have you, and in those cases, um, power, uh, sustainable power, is going to change in terms of what is tolerable. If you go to higher altitude or hotter weather, you're not going to be able to sustain the same functional threshold power, or FTP, that you would if it was cooler weather at sea level. You just won't. So um, the practical day-to-day use of running power, if you really want to start dialing it in, you can start adjusting your targets, whether they be training targets or racing targets, based on your temperature, your humidity, your altitude, if it changes versus what your baseline is. So let me go over this. First, I'm going to just go over the workbook. I want to acknowledge the folks at Stride for putting together a conversion tool that allows conversion from altitude or temperature or humidity, so you can account for these various conditions. I also want to acknowledge Steve Bateman for his race power planner that includes both the Rigel formula as well as running effectiveness to estimate target race power and just a estimated time outcome from if the estimated power and estimated running effectiveness were true. So the acknowledge to both Stride for their part in this and Steve Bateman for his part in this. Uh, and then there's a few other parts that I've built. So the workbook has 4 worksheets. That starts with the Stride work, which basically I've modified to remove the power target and power result. Um, the bottom line is the correction factor, the percent change, doesn't it's dependent on these variables, and it applies across whatever power you happen to put in. So I stripped that out. I put it in later on. I also added for my own use the ability to convert feet to meters and Fahrenheit to Celsius, since the model uses degrees Celsius for temperature input and meters in altitude for input. So that's worksheet 1. Worksheet 2 is simply applying the correction factor, or actually percent change, applying that to whatever you enter as your baseline. So whatever you're changing it from, if it's your FTP at your normal training conditions and you are going to altitude, let's say, you would apply those condition changes in here, and then you put your FTP in. It produces what your FTP would be here. Right now, I have everything set up for uh, the from and to is identical, so it means it's just you're continuing to train in your normal environment and conditions. So 300 equals 300 if conditions are not changed. Um, that's the second page. So this takes the original calculations to produce a correction factor, and then produces the actual change in power for your FTP. The next page is our worksheet is one of mine. What it does is it takes your FTP that you put in from your baseline, and it just draws in the conditions that you put. These are not, you don't enter them in here. They're just drawing them in from the worksheet 1. And this draws your power in that you put in on worksheet 2. Just draws that in, and then it pops out your zones for that particular power, that FTP, your Palladino Power Project zones. And there's a little description here. So it pops those ranges, those zones in, populates them for this particular power. And then this is something I've used some of my athletes. Let's say, I'm not training by zone particularly. I'm training a target. So let's say I want to know what 95 or 96%, let's say. 96% of that particular FTP is 288 watts. Or let's say I'm working the other way around. Let's say I want them to hit 250 watts. What percent is that? That's 83.3, and I am going to change that really quick to this. So it's about 83%. So it just gives you an idea, the opportunity to work within that domain of functional threshold power, which was set for these from conditions, your baseline. But this sheet also auto-populates whatever the 2 is, and I'll come back and play with this so I can show you this. So it'll populate whatever the 2 FTP is, the conditions that you had put for the 2 conditions, and then it will populate your zones for that particular value, and it'll also allow you to come in here and do the same thing if you want to check what a certain percentage, what power that is, or what power, what that translates to in terms of percentage for this particular power, the 2 power. So that's the third page, our third worksheet, training corrections. Then there is the Steve Bateman Race Power Planner. Basically what I did here is I converted his sheet to, it draws in the from conditions and the to conditions. Now this sheet will produce race power targets based on this 2. So this would be your baseline that you put in back on sheet 2. This is going to be your new FTP at the new conditions. And then it'll estimate your race power targets based on that. We'll come in and use this and show you how that works in just a moment. And then the last worksheet that I have is, let's say you have a race and it's under conditions that are different than what you typically train at. Let's say you went up to altitude and you did a race up there, and it was, you really had a great race. You will come in and put the time and power for that race under those conditions, which would be your conditions for the from. You'd have to go back and make sure you put the from conditions in, and then you put the 2 conditions in, and it'll compute your FTP for the new conditions. So let me see if I can give you a few examples. So example 1, let's take a person who normally trains near sea level, 150 meters, and let's say they're going to be going up to 5,000 feet for training. That's 1524. Let's say that they normally train at about 18 degrees Celsius, and we're going to say they're going to be closer to 26. Humidity, we'll say a little bit lower humidity in this situation because they're up at altitude. And let's say we'll bump this up to 40%. All right, so you can see under these conditions, the correction factor is 0.947. That means they will lose power, about 5.3% of their power, whether it's their FTP or their 5K power or their 5-minute interval power, whatever the case may be. So if we come over here, let's say that their FTP at 150 meters, 18 degrees, 40% humidity is 320. What does that translate to? That translates to 303 watts at that 1524 meters, 26.7 Celsius, and 20% humidity. So their FTP, where they're going to start training, is going to be 303. So then we come over here to this worksheet, the training corrections worksheet, and it auto-populates. This is their sea level zones. So those are the conditions. It just auto-populates that, and auto-populates whatever you put in that cell in step 2. It auto-populates what the zones are and what the FTP is for those new conditions, which is the altitude with a little bit higher temperature, lower humidity. And then, let's say you want them to do tempo at 94%, 285 to, let's say 96% is the range. So for this altitude temperature, they'd be targeting 285 to 291 for 94 to 96% of FTP tempo. Now, let's say the person was going, instead of going up to train, let's say they're going up to race. All right, and let's say they're going to do a 10K. Let's say this person is 65 kilograms. They're doing a 10K up there. I'm not sure what that will end up being, so I'm just going to guess 36 minutes. Let's say they're they're pretty fit person. Let's say the regular X point is somewhere maybe minus 0.06 or minus 0.07. So we'll use those two inputs here. And let's say their target RE. Let's say we're expecting them for this race, let's say their prior 10Ks at sea level, it might have been 1.00. This one's a little hillier. We'll say a 0.99 to 0.98. Same thing here, 0.99, 0.98. So now we sort of bracketed for going up the altitude and the warmer temperature. The target, you can sort of see it's sort of hovering between 309, 311 as the best case scenario, and the estimated time, if they achieve that particular running effectiveness, is somewhere between 35:15 and 35:45. So that's how this would be used. It just takes whatever you put in the to conditions and the from conditions and in step 2, and just auto populates that in. All right, so I'm going to use a different scenario for this one over here. Let's go back to step 1. Let's say the person does not change their altitude. Let's just say their last CP test or their last race on which their FTP or CP is based. Let's say it was let's say it was done back in March, which is quite a while ago, but let's say it's somewhere in March, and that morning of the race, it was about 15.6. 15.6, and let's say that now their typical training conditions are somewhere around 23.9. Let's say the humidity doesn't change much. We'll say maybe a little bit higher humidity here, a little lower humidity there, whatever the case may be. I'm just making an example. So for that scenario where now you're training in warmer conditions, it's probably not the best idea to use the same FTP from those cooler conditions, and you want to adjust training targets, etc. So with this scenario, the percent change is minus 1.18, which is not a big deal. So this person probably could train under the old CP. That's not a huge change, but if there's a bigger change, let's say they're running into some quite warm temperatures, say 29.4 degrees Celsius. So now we're getting to something more significant, 3% change, which for someone with 300 watts, that's a 9-watt difference in that particular target. So the let's say their FTP was 320. Under the warmer conditions at the same altitude, they're now roughly about 310 watts would be their equivalent CP. And now you can come one step further and take that from, this is the 2, this is what it came up with under those conditions. Now you get new zones and new target. So 96% in the cooler temperatures, that runner would be running 307 watts. 96% of FTP in these hotter temperatures, 297 watts. All right, so that's a significant change. If someone was trying to hold the same power that they normally do in cool temperatures, they're probably going to blow up. If they're doing 20 minute, 2 times 20 minutes at 96%, this is going to be pretty hard under those conditions, as you can see here. So there's another scenario. You could do the same thing going. Let's say they're going the opposite direction in the fall. Let's say you had August. It was hotter and 29.4, and they're now dropping down to 15-degree temperatures in the fall. We'll reverse this down here. Same altitude because they're not changing locations. They're same place. It's just temperature change. They're in the summer. Let's say their FTP had climbed to maybe 315 watts under those warm conditions, which are listed right here, just drawn from the previous worksheet. It'd be equal to about 331 watts now under these cooler temperatures. So once again, their new oops, saw something. 325 watts would be the corrected. Didn't click enter. I caught that down here when I saw this. So this would be their new fall power targets. Now, of course, my recommendation is whenever you go to a new set of conditions, let's say you're going to altitude. Initially you're not going to do a CP test the first day you get up there, but after acclimating, after about 2 weeks, maybe 2 to 3 weeks, you're going to definitely want to get a CP test and get an accurate reading rather than just do these calculated conversions. Same thing when you go from cool weather to hot weather. You're going to want to redo a CP test or a race that's more in line with your current training conditions. So Calculations work initially, but then you want to back it up with some confirmation of CP tests under those conditions after you've acclimated for 2 or 3 weeks in the new conditions. And I'm just throwing 2 to 3 weeks out there as a general recommendation. It's not a carved in stone sort of recommendation. I've already gone over this particular worksheet here, but let's work with this one. All right, so this one is going to work a little bit differently. So let's say that we went and did a race up at 5,000 feet, and we normally train at sea level. And let's say the temperature there was, we'll say 18, and let's say your normal training temperature is about 18, and humidity may be a little bit lower at the altitude, so we'll put 20% here. Just whatever the atmospheric conditions were at the time of the race. So the from is where the race was, and the to is you're figuring out what it's going to be when you go back. What FTP might it be from that race when you go back to your normal training conditions, which is the to. So you race conditions, to condition, your training conditions, and you come back here to the sheet 4, and again, let's say it's a 10K, and let's say it was 39.25. I'm just going to change these. Really, I just thought of something where I can change this so it's all these others flow from just one entry. So you only have to enter one race time, and the power. Okay, so the power is whatever you did at the race at altitude. Let's change that to 282, 282, 282. And let's say you know that for 10K, your Rigel exponent is like, let's say, minus 0.07 to minus 0.08. All right? So the FTP, the FTP for the from conditions, in other words, for that race, if you continue to train it at that altitude, your FTP should be about 277. That would be your new estimate to use as another data point in coming up with your FTP estimate. But when you go down to sea level, that race produces an estimated 290 watt FTP estimate. So there you go, and I hope that this is a helpful sheet for you. At least what I've used it. I've not made it available yet. I'm still working on it, obviously, but gives you an idea of how when you run with power, you can be a little bit more specific in your training and racing targets based on conditions such as altitude, heat, and humidity. Thanks a lot. I hope you liked it. You take care.